Yes, good morning, everyone.
Good morning.
Good morning, sir.
Yes, good morning.
Yeah, still only 30 members. 30 members are there, sir.
Yes. How many registrations are there?
735 registrations are there, sir.
And your college has been opened?
No, sir. We are conducting online. We are taking online classes.
No. Yes, I think your head of the department is inside the campus, and I
Yes,
think
sir.
some
Yes,
of.
sir. Yes, sir.
Okay, so limited faculty members are there in the campus.
Yes, sir.
Okay. So how many means 50%?
Yeah, 50%. Will you wait 5 minutes, sir?
Yes, we can. So in this FDP means faculty members from different part of India.
Yes, sir. Different out of India. 5 members are there, sir. 5, 6 members are there. Okay, throughout India, different states.
Okay.
Yes, I want to give a small clarification to all the participants, sir. 1 minute. Shall I, sir?
Yes, please.
Yeah. Yeah, once again. Yeah, very good morning to all the participants. Regarding certifications, I want to give a small clarity. Participation certificate is as usual. That depends on your presence and feedback, everyday feedback. So NVIDIA certificate is an additional certificate what we are providing from our Sttp. So with the help of Gupta sir. So those who are not completed a certificate, I request you, please, if you do that assessment, then only you can get your certificate. We are not providing directly. If you do that NVIDIA assessment, then only you can get a certificate. Last 2 days, continuously, we supported all the participants for getting of that NVIDIA certificate. So please try to understand. And next, participation certificate is as usual. That depends on your presence and feedback. This end of Saturday, this end of this Sttp, we are conducting a small exam, quiz type exam. It depends on score. You are going to get your certificate. So try to understand that.
Sir, in between, for some sessions, we have to take certain online classes that may be clashing. I mean, today afternoon one class, 1 hour, and tomorrow also. Tomorrow I have to session from 2 to 5 o'clock. So I'm just thinking about what to do, because I'm taking for IIIT Kurnool some classes. I'm a adjunct professor there.
Okay, sir.
Also, I'm also at Nanjala some classes. Okay, Nanjala one meetings and all that. Okay.
Okay, sir.
Okay. So today, tomorrow, Thursday, Fridays, actually I have classes. But today one anyhow, in between the afternoon 2 to 4 o'clock I have the class. And then tomorrow also I have some class.
Okay, sir, no problem.
Okay, so only 61 participants are there.
Yes,
so
sir. Yes, sir.
We can wait for a couple of minutes. So because yesterday that one is not completed, actually that some sections are there in the CNN,
Yes, sir.
and that is equally important actually.
Yeah.
So I'll cover that some of the topic, and then we go ahead. So even though those who are there in the workshop make and write if they have some query in the chat window. So quickly I'll cover that one also without wasting the time.
Sure, sure.
Okay, so please anyone just can type the question and let's see if I'm able to answer it, then definitely I'll answer it.
So the padding one you have explained yesterday.
Yes.
So apart from that, you have shown a 5 by 5 matrix. You have added all the boundaries with 0 as an element, right?
Yes.
And then with the filter, this one we generated this one, right?
Yes.
Okay. So that part of the adding the surface, all the one element around in the body, that's called padding, right?
Yes. Yes. So zero padding actually.
0 padding. Okay.
So what we are doing to retain the size of input matrix, what we can do, we can add the zeros in the corner. Okay. So that is also dependent on the size of the filter actually. So suppose you go with the 3 by 3, then 2 rows and 2 columns are added. If you go with the 5 by 5, then you have to change the size of the padding. Because again, if you use 5 by 5, if you go with the in same fashion, so dimension will change.
So, but you have shown for the 5 by 5 matrix and 3 by 3 filter, you added one row or one column of padding, right?
Yes, yes, yes.
But how it is connected with the filter size and that part? I thought only one row or one column adding is the padding. I thought.
No, let's say if you go with the 7 by 7 filter size, and you apply and you check it. So 7 by 7 matrix is there, and 7 by 7 filter size is there. In that case, what will happen? You will get only single value.
Correct. Okay.
Okay, but you want to make a 7 by 7 matrix itself again. So you have to add means more pad.
I see.
So actually, while writing you the code, so what is actually happening? You have to simply put same. One keyword is there, same. So using or padding, you can make it true. So if you go with in this manner, then the size will remain same, no problem. So coding point of view, it is so easy, but theoretically you have to means map. So how you can map? Simply, simple concept is there. After applying the padding, the size of the input matrix is remain constant after applying the filter. That's fine, nothing else.
Sir, then the filter you have shown in that in the padding filter, the
Yes.
inside elements 1 multiplied by 1
Yes.
0. What is that meaning?
No, so basically it's a correlation operation is nothing. It's a dot product of individual elements.
I see.
And sum of it.
And then sum of it also.
Yes. So can please the admin can give me the permission to share the screen so that I can.
We are not able to see your this one also. Yes.
Yeah, actually it is disabled for me screen sharing. Okay, so I'm requesting to admin, please give me the right to share my screen so that.
Now it is there. Okay. Sir, yeah, we thought that see the max filter and all that, picking up the max element, and one first one you showed the elements. Then in the padding, I thought because it is that filter is giving only one value, means picking up which one. When the addition is there, some it will do some value different, right?
No, sir. Actually, one pixel value, one weighted sum, like that.
And also strides is basically the sliding the window, right? Stride is basically meant for.
Yes. So the concept of sliding is how simple. Means how many rows or how many columns you want to skip actually.
Okay.
So sliding equal to 1.
3 means 3 rows to skip. Huh?
Yeah. So you have to skip the 3 rows and 3 columns every time in each iteration.
Oh. So first one you strided with 1. S is equal to 1.
Yeah. By default, stride equal to 1. If you will not define the stride, then it means it is equal to 1.
I see. Okay.
Sir, I have a question, sir.
Yes.
The thing is that if in AlexNet, for example,
yes.
you have 227 by 227 into 3. 3 is RGB.
Yes.
Okay.
Yes.
You're multiplying with 11 cross 11 filter with stride of 4. Okay. Okay. So when you multiply, then all the 3 colors will it come into 1 color. Means you're taking it as an average of the 3.
Yes. Yes. Okay. Perfect.
So in that you took 96 filters in the second layer. Number of filters is equal to 55 into 55 into 96, right?
No, the depth became 96. That's another question. So the depth is increased actually.
So depth, SAR took 96 filters. So why are we taking 96 filters, sir? Because the question is that anyhow your filter is nothing but the weights.
Yeah, of course.
Okay, so when you're taking with 1 filter only, we get a filter weights, or if you take 10 filters, we are randomly by back propagation or forward propagation, we are getting it, right? So why are we taking 96? Why can't we take with the 10 filters only?
Yeah, perfect. So actually, what is happening? There is no thumb rule to select the number of filters, number of layers. As such, there is no thumb rule. So what they did, they have started with, I think, some more number of filters. Okay, randomly, let's say they have started with 128. First, they build the model, reach a particular accuracy, let's say 98% or 99%. After then, they try to compress the model. So for compressing the model, network slimming is there, pruning is there. So some different kind of methods are there where they reduce the number of filters in each layer. So recently, we also communicated one article in IEEE transaction where we have applied genetic algorithm to compress the neural network model. So in our case, we achieved a remarkable accuracy. So previously it was, I think 60-70% in BG16 in MNIST dataset. Now we reached to the 99.32% compression in MNIST dataset. Okay, so first you build a model, a simple app architecture bana lo, but after building that model, you have to compress that model. So compression is another area how you can compress the neural network model.
So it's only the trial and accuracy. So keep on experimenting it, and when you get a correct accuracy, that is the baseline we have to put it.
Yes, no. So you have to go with some certain number of combination of parameters. I think actually I miss it as per the discussion with the Professor Oblises. They told me that all the participants know about all the fundamentals of deep learning. So that's why I didn't cover that hyperparameter tuning section. But if you required, I'll also cover it. What are the hyperparameters? How you can choose it? So I didn't cover it actually, with the assumption that all of you know about it. But in short, I'll let you know that you have to start with some random set of the parameters. Let's say by size is 128, then 3 layers or 4 layers architecture with random number of filters like 128 or 256. So first you build a model, a random model, and let's say you reach to the appropriate accuracy, let's say 97% or 98% or 93%. Some cases it is 70% also. If we talk about the ImageNet challenge, ImageNet data, if we are going to use, so accuracy is near about 60 or 70%. Okay, so first you reach to the accuracy up to that level, and then you have to compress the model. So for model compression, some different techniques are there, and using that model, what you can do when you compress it. So after then you will landed at like 96 filter or 54 filters or kind of.
Thank you, sir.
So you have to start from the hit and trial methods. And once you get the appropriate accuracy, then you have to compress the model. So
Sir, yes, hello.
yes.
Hello, sir. Sir, is there any deep learning course for cyber security from NVIDIA?
NVIDIA, yes, but all that are the paid actually.
Oh, okay, sir.
Some courses are there, but all they are paid. So it is good if you go with some. I think the charges of courses are too high. So what you can do, yes, around 20,000-30,000. So rather than what you can do, you collect some of the videos from YouTube. Lots of materials are available. And suppose you are working in the research in that domain. So just you collect the things, and one website is there. I'm writing it here, paper with code, okay, .com. So I have written this in the chat window.
Okay, sir. Yeah.
So if you search the article in this website, so you will find the code of that paper also.
Okay, okay, sir. Okay.
Yes.
From RGB 3 layer filter, this one, and the filter was 3 by 11 by 11 3 times. Then it becomes, say, how it the next level, it went to 96 level.
Yes,
96.
I'm coming to that. Okay, fine, no problem. Okay, so this is my slide. I think all of you are visible because lots of confusion are there in LXNet architecture. Yeah, it should be there because if you are able to understand this architecture, you can easily work or easily understand other famous architecture. Okay, just in the domain of deep learning. So just here you can see that what is the input size. So input size is 227 by 227 by 3. Maybe possible you don't have the image because this architecture has been developed for this kind of image. Okay. So here just you can see this is your input size. So let's say you have the image of size 220 by 220, and you want to apply LXNet on this kind of images. So you have to convert this image in this form, all the data. Otherwise, you have to provide the change in the code, and maybe possible to provide the change in the code, it's quite difficult. So if such kind of situation is there, then just you use the Cv2 and convert all the images in form of 227 by 227 by 3. Okay, now many of you are facing the challenge, what is the meaning of this 96? Okay, so I'll let you know, very simple. Any question regarding this 11 by 11 and S? I don't
11 by 11 also, actually it is a depth of 3, right? That filter size.
No. 11 by 11 is the size of the filter. This is a filter.
But for RGB, you said, say, let me say for RGB.
I'm coming to that, don't worry. So this is the filter size, 11 by 11. And what is the depth of the filter? That is 3. Why 3? Because depth of the image is 3.
Correct.
So by default, it is 3.
Correct.
Okay. So when you apply this 11 by 11 by 3 filter on these images, so you will get a single image of size 55 by 55.
Oh, correct, sir. Correct.
Okay, with this stride 4. Why it is so? So 227 is the image size minus minus 11 is the filter size divided by stride. So it is equal to 54 plus 1 equal to 55. So from this formula, you are able to get this 55 by 55. Now the question is that if you apply a single filter, you will get a matrix of size 55 by 55. If you apply 2 filters, then with respect to another filter, again you will get a size of means matrix of size 55 by 55.
Oh, like that.
If you apply 3 filter, then it is 55 by 50. If I'll combine it, then what is the situation? So 55 by 55 by 3.
Yes,
but here the answer is 96.
96 times you have.
Yes. So here 96 is there. So it means you have applied the 96 filter.
Okay, sir.
So at this position, 96 filters are there.
Okay.
That's why it is 96.
Okay. Okay.
So 96 number is random. So
No. It is not a random, because okay. So if you want to generate a random number, then I don't think so anyone generate 96. Means I'll speak. Means I'll ask you.
Right.
Just give me a random number. So you go with 100 or 150, 200, 250, 28, 32 kind of. It's very rare. 96. So basically what they did, they have started with the LXNet with the either 128 or 256 number of filters. So just they have put all the filters, and after then they try to compress that model. So such kind of figure 96, here just you can see 256, here 384. I don't think so, it's very rare. If randomly, if you ask a person to generate a random number between 1 to 500, so it's very rare that he will tell you 384. It's very
that
rare.
means, sir, so is it so that means it is this number has come after number of trials?
No. They build a model. Just again, give a weight on my thoughts. So just they have built a model. Let's say with in each layer 128 filters, somewhere 256 filters, somewhere 512 filters. Okay. So in this manner, they have built the architecture. After building the architecture, they have applied the model compression technique, like network theming, like pruning, okay, or any other maybe optimization technique. So after applying that, they have landed with these number of filters in each layer.
Okay.
So in model compression, I'll discuss with one technique, whatever we have applied in the past. Recently, we have applied, okay, for the compression of the model. And at there, I'll discuss with the result also. Don't worry for that.
Sir, from 27 by 27 by 96 to 27 by 27 by 56. Sir. There it's at 5 by 5 filter, 5 by 5 and depth is 96, right? Then it becomes 27 by 27. Like that, 256 times you have to do it. Right?
So at this position, the size of the filter is 5 by 5 by 96.
Correct.
So actually we are not considering the depth. So as we know that the depth of the filter is always same as the depth of the image. That's why it is the case.
Correct.
The stride, how to choose stride?
No, it depends on the size of your input matrix. So let's say you are working with 4096 by 4096 matrix or image size. In that case, you can go with the higher side of this stride. Because you see, in neural network, what is actually happening? In neural network, you have to multiply the input with some weight value, okay? And if the size of the matrix is too large, okay? So if the size of the matrix is large, at that time you have to, you have to apply too much number of operation, and it will take too much of time. So what you can do with respect to your input size or input information or input data, intelligently you have to select this stride. So what you can do, you start with 4, 5, 6, 7, even though you can go to the 10 or 11 also. So based on the size, you can select. But as such, there is no thumb rule. If a thumb rule is there, then there is no meaning of discussing about this stride. You can simply put a stride is always 10 or a stride is always 1. So now say, let's say you have a image size of 28 by 28, like this, what we call the handwritten digit MNIST data set. Okay, suppose you are working with 28 by 28 image size and the stride is 4. Okay, so after first iteration, the size of your image is directly converted to 7 by 7. It means you are losing around 75% of the information, and maybe possibly you will not get a very good result. So you have to think Means size, this is my size of the image, so I can go with this style, or even though you can go with the hit and trial method also. So it may be there.
Sir, if we are using the ready models, like for example, SSD or faster RCNN network, so can we change the parameters in that and use?
Yes, you can change. So in YOLO, you can change. So some of the hyperparameters are there. Okay.
Okay. Yeah.
So just you can go through that hyperparameter and you can change. But already, like if we talk about the YOLO, let's say we are talking about the YOLO. So already the architecture is optimized. Okay. Already the weights are optimized because in background they have trained that model with large number of data sets. So if
Yeah.
already that is optimized, so it is not good to change the hyperparameters.
Okay. But then if we are experimenting on our data, our own data, so what are the things that we can change and then compare maybe?
So in case of, if you talk about the CNN model, then learning rate, batch size, these are the hyperparameters. Okay, so
Okay.
many hyperparameters are there. Let me uh, check. I
Sir,
think
we
in
can
first
check with
slide,
the
yes,
application function also.
yes, I'm coming to that point. So I think in first day I have shared a slide, and in that slide, if you come right here, just you can see these are the hyperparameters. I don't know all of
Okay.
you have checked it or not. So learning rate, hidden units, mini batch size, and then you can go with the optimizer, even though you can go with the activation function, even though you can change the number of layers. Okay, so these are the hyperparameters. So first of all, we have to think about the learning rate. Okay, so first you try with the learning rate. So learning rate, let's say by default, it is kind of 10 power minus 3. What you can do, you go with the 10 power minus 4, you go with the 10 power minus 2. Make all the parameters constant, but you only change the learning rate. In next step, just you see, let's say you go with 10 power minus 4, accuracy will not improve. So it means if you again you go down for the 10 power minus 5, probably you will not get the good accuracy. So in this manner, you have to apply some of the hit and trial methods, and then you have to compress that model. Okay, but always remember, most of you are working or pursuing the research in the application of the deep learning.
Yes.
So only proposing a CNN model, it will not considered as a what we call contribution. It will not considered as a contribution. So now what you can do, so you have to provide some kind of innovation. So I'm taking one example. Okay, I don't know. This is my view. So let's say one medical domain, one major problem is there right now, that is uh, what we call retinopathy related to diabetic retinopathy. This is a problem actually. So the size of that image is too large. Okay, so what we can do for a single image, you convert or the means the original image is converted in 4 quadrants. For it, you apply a kind of CNN. Okay, for this you apply the CNN. Okay, for it again, for each and individual you apply the CNN model. Okay, combine the result like this. Okay, combine the result, and then again you use some kind of inception or resonate or inception unit. Okay, and then try to combine. So this now after combining it, you have to prove that why this method you have chosen. So mathematically, theoretically, you have to maybe possible to extraction of the feature. So you can declare it as a feature extraction module. So many things are there. Means you have to provide the some kind of contribution. Even though you can use the Google ResNet block, okay, ResNet block, inception block, two block you can use in your CNN architecture, and then you prove that features are extracted by this this ResNet block. Some features are extracted with the inception block, and by combining both of the features, I passed these features in the CNN network, and then we reached to, or we got this much of accuracy. So likewise, these are some tips and tricks to provide the contribution. But already in the past, many researchers has applied such kind of technique. Okay, so even though maybe possible such kind of article will not be accepted, so please you have to think and you have to be care about all such kind of things. So only plain CNN, if you go with the plain CNN, the paper will not be accepted right now. Even though if you want to provide some kind of contribution, then you can generate a new loss function. This is also a contribution. Generate a new activation function. It is also a kind of contribution. New grid means new techniques for the backward propagation. So all such are the, you can say that contribution.
Sir, one quick question, sir.
Yes.
During this filter to filter conversion, I understand that we are using n plus 2 f minus, the formula
n minus f.
N minus f by a plus 1. But problem here is, if you go to the LXNet, use in 27 by cross 27 into 96, it has into same thing, 27 into 27 into 96. So if you minus 27 minus 5 is 22, or 20 plus 1 is 23, sir. Why did we get it as 20, as again 27 cross 27 into 56?
Okay, so here just you can see the formula is n plus 2p, just wait, n plus 2p minus f divided by s plus 1. This is the formula actually.
Right.
Okay, so n is 227, p is 0, so minus f equal to 11, okay, and stride equal to 4, so this is 4 plus 1. I think it is 55 by 55.
Yeah, that is correct, sir. When you get it from 27 to 27, I'm getting confused there.
Okay, so 27 by, so here just you can see one word is there, that is same. And same means the size of the input matrix and the size of the output matrix always be same. Okay, so it means what we are doing at here, we are here applying a padding. Hello, yes, Professor. So it is written as same. So same means padding has been applied. So if padding has been applied, then the size of the input matrix is always equal to the size of the output matrix.
Okay, got it, sir.
Okay, and one more thing I would like to convey, because most of you are the teaching profession and it's quite difficult to write the code. Okay, so I would suggest all of you search, let's say suppose you are working in the object detection model or object detection problem. Okay, so in GitHub, with respect to object detection, lots of models are there. So simply you copy paste that code, execute that code, just you check your result, and whatever your innovation is there, just you modify the code with respect to that innovation. Okay, so don't try to build a code from the scratch. It's very difficult. If you are working in the CNN means image classification, lots of CNN models are there already. Just you search in the GitHub, you will find a penalty of CNN model. You can take anyone and just you try to map that model with respect to your data, because you have to provide some of the changes like size of the image will not match. Okay, so what you can do, just provide a simple image processing concept, okay, and change your image size, pass in that model, and you will get a very good result. So with minimum effort, you are able to execute the codes related to deep learning. And penalty of codes are there for each work. Either you work with the segmentation, either you work with the beautification, either you work with the image classification, then detection, everything. For everything, you will get penalty of code. Okay, so I think any other question, then just you can ask. So 120 participants are there. So if anyone has any question, then you can ask, because today it is going good. There is no kiosk. One is asking the question and other will get it.
Hello, sir.
Yes, please.
Sir, only one doubt I also asked yesterday. Like people tell that like here we do convolution operation and some tell like correlation operation. I am confused like whether we do convolution operation or correlation operation in the CNN part, sir.
No, so in CNN actually what is happening, while you are applying the CNN, then if you see nearby pixel values, so okay, just you let me tell you the CNN operation. So okay, here just you can see. I think my screen is visible. So here just you can see convolution example is there. So what we are doing in convolution operation, this matrix is performed or passed at here. Now this value is dependent on all these 9 values. Okay, so
Yes,
this value, yes, this value is dependent on the nearby pixel value. Okay, so what we are trying to do while reducing the size of the input matrix, actually what we are doing, we are correlating the nearby pixel values, and against that we are putting a new value. Okay, so kind of correlation is also captured during the convolution operation.
Okay, sir. So we're doing correlation operations, sir, like matrix multiplication, whatever we are doing that dot product operation, it is correlation operation.
Yes, something, no. This is a definition of the convolution operation. But if you see indirect effect of convolution operation, what is the indirect effect of convolution operation? That it is also finding or correlating the nearby pixel values.
Sir, in convolution, they said like the kernel is shifted by 90 degrees or 180 degrees. I heard something like that, sir. In convolution. No. We do not apply the filter directly. We rotate the filter and apply.
I don't know in which perspective you are talking, but here just you can see what is actually happening. Just a minute. Okay. So now what we are doing, we are right now our filter on these values. After then we have to shift this filter and start from here 057 and goes up to this. Again start from here and ended at here, then again. So this is a kind of horizontal shifting and vertical shifting. When you complete the column wise operation, then you have to shift it by in row wise. So you will start from here and end at here. This section will be convoluted. Again you have to shift. So this is, I don't know means which perspective you are talking, means in 180 degree and kind of 90 degree. I have to go with more detail about that one.
And how does this weight updation is done in CNN, sir? Okay,
so again you have to go with the Just wait. Okay. So here some space is there. So this is your CNN network again. Okay. And you pass the image, same image. Such kind of connections are there. Okay. Now here it is connected. Likewise,
Sir,
like neural
this
network.
is a neural network, no, sir. I'm asking
Yes.
in a filter, sir. How the weights are updated?
Yeah, coming to that point. Don't worry. Okay.
Yes.
So at here you calculate the loss. On
Yes,
the
sir.
basis of that loss, you have to update the weight and bias inside of the filter.
Yes, sir.
Okay. So same process is there in convolution neural network. Same thing is there. You have to calculate the loss, and with respect to loss, you have to update the weight stored inside the filter. So previously in ANN, what is actually happening? Each and every nodes are there, but here only connections are there, and with respect to that connection, you have to change the either 9 weight values or 4x4 or 5x5 filter is there, then 25 values. So
Okay,
as per the calculated gradient, you will provide the change. So let's say in 3x3 filter, let's say 0.9 minus 0.5, 3, 9, 6, some kind of values are there. So whatever gradient you have calculated, based on that gradient, maybe possible a slight change is there. So in some weight, very slight change is there. So 0.9, minus 0.532 is there. In place of minus 0.5, it is 0.43. In place of 9, it is 8.4, 6.1, kind of, or 6.1, kind of. So that is actually automatically happening. Yeah, of course, we have to intuit that what is actually happening inside the this what we call the convolution neural network. And even though in Keras, in TensorFlow, you can print the weight also. So suppose you want to compare the weight values before and after convolution, you can do it. Okay, so you can compare it. No problem.
Okay, sir. Got it, sir. Thank you.
Oh, good morning, sir. I'm Dr. Tilotma Goswami from Anurag University. I have one question, sir.
Please, madam.
Actually, when we are doing the transfer learning, then the weights are already fixed with the model. So we can use it with our high-end, whatever laptop we are having. In case we want to train that same model with our images, then do you think it will be better to have a GPU?
Yes, just okay, ma'am. In case of transfer learning, actually, what happening? Let's say you are copying, means you are utilizing the architecture as well as weight also. Okay, so you can utilize that one also. Maybe possible you can freeze the 50% or 60% layer of the pre-trained model. Rest of the layers you can train. This is another method. Third method is there, that is you can only utilize the architecture. So this is also a way. But yes, of course, GPUs are required while you are going to train your model from the scratch.
Yes,
but if you go with the transfer learning, I don't think so GPU is required, because in the transfer learning, you have to means train some of the layers. Throughout the network, you no need to train the whole network. So some of the layers you can easily train using the CPU. Even though you can utilize this transfer learning model in cloud also, either in Colab, either in Azure.
Okay, thank you, sir.
Sir, Sunil sir, good morning, sir. Hello.
Yes, hello, sir. Good morning.
Sir, if we configure the model with multiple filters, each filter extract different features from the text or image? That is my question. Each filter extracts different features?
Yes, yeah. Actually, you are correct. We have experimented it with also. So each different filter, let's say if you go with the 1000 filter, so maybe possible some of the overlapping is there, maybe possible some of the filters extracting the similar kind of information, maybe possible. So even though if you go with the 32 filter, so quite possible that more than 50% filter is extracting the different feature, but in some of the filters overlapping is there, in some of the filters you can say that same information will be extracted. So all such kind of things are possible.
So okay, so for text analysis, which model is suitable for applying, sir?
No, for the text analysis you have to work with the LSTM. Yes.
So, okay, sir.
LSTM is good for time series data.
Okay, sir. Okay,
so,
sir.
Like the data is stored in the Excel file, data in the form of video, data in the form of audio, data in the form of text. Okay, so for such kind of thing, you can go with the this what we call the
LSTM.
Yes.
Okay, sir. One more question. So how can we use pre-trained models on our data set?
Means?
So, for example, pre-trained models, that is, you said in previous lecture, the pre-trained models are, that means transfer learning. As a part of the transfer learning, you will use the pre-trained models with your own data set, like that you said, na? So how can we use the pre-trained models with our own data sets?
Okay. So I think, I don't know, study lab, all of you gone through the complete lab or not? Because at there I have used in that lab I have used VG16. One exercise is there.
Oh, okay.
Yes.
So in this collab, you exercised VG16 pre-trained model with your image data set.
Yeah, I'll let you show. I don't think so. Means if you have gone through that exercise or complete lab, all such means we have experimented with this pre-trained model also.
Okay.
Just wait, I'll show you. Here, just you can see mobile net model. Okay.
Okay, sir.
So here, just you see weights equal to ImageNet.
ImageNet. That is a pre-trained model weights.
Yes, pre-trained model weights.
Okay.
So here we are going to use the mobile net. Okay. Mobile net is the model, and here weights equal to ImageNet. It means we are copying the existing weight. So using a single line, you can utilize the architecture. So don't worry for that. Means suppose you want to utilize the VG16, so some predefined code is there for the VG16, or just I'll search it. All of you just go through how to use the VGG16.
Sir, yesterday after AlexNet, you explained something for mobile net. That 2-3 slides that was actually which I couldn't get. It was hanging and other things. Can you little show that slide? What is that mobile net one?
Okay, no problem. Yeah, this is the inception network actually.
Correct. Inception network.
So here just you can see this is the architecture of inception network.
No, inception network I have seen, but before that you said about mobile net something like that.
Yeah, just I'm coming to. So this is the single unit of inception network. I think so. You are talking about this one.
Okay, sir. Okay.
Okay, so only 2 slides are there. So basically, this is a inception unit. Okay, and this number of inception units are there. And what is inside the inception unit? Because here it's very difficult to see. So this kind of operation will be taken place inside the inception unit. Okay, so these are inception network or inception block, DressNet, and one more called the mobile net. These are very big architecture.
Sir, this one this one, what is that 20 by 28 and then different the right side?
Yeah, I'm coming. Yeah, okay, I'll explain it. Okay, so here one image is there. Okay, so the image is 28 by 28. Okay, and in this image here, just you can see 64, 128, 32, 32. So basically what is happening, we are performing a condition filter actually. Okay, so number of filters is given at here. These are the number of filters. Okay, so some kind of image was there, let's say 28 by 28, 16. It means 16 filters has been applied previously, and this data is passed throughout this network or this block. Okay, so it is converted or looking like this one. So this complete, you see, this complete after channel concatenation, it is looking like this. So here what we are doing, we are concatenating the all the data.
Okay.
So this is looking like this.
Sir, actually, what is the importance of channels here, sir? Why we have to apply the channel concept to CNN model?
Channel
Hello, sir.
concatenation, no, yes. So actually they have proposed, I don't know what was the intention for the channel concatenation.
Okay.
Okay, so I don't know.
My question is why channel concept is came into existence. Why we have to apply multiple channels are there now while configuring the input to the model.
Yeah, that's fine, but I
While
don't know what. Yes, no, Professor, I don't know what was the motivation to concatenate the channel. So I don't know actually, so I can't say anything about it.
So, so we will configure the model with multiple channels. Now, how we will decide how many number of channels has to be has to be considered in our model? So, is there any thumb rule behind
No,
that?
as such, there is no thumb rule to select the hyperparameter.
Okay, sir.
So no thumb rule. Other if thumb rule is there, then rather than studying all such kind of things, we study the simple. If you want to, this problem is there, these are the steps. This problem, these are the steps. That's fine. There is no need to study all the things.
Sir, in this slide below, maximum pool 3 by 3 and stride is equal to 1. Same. What is the meaning of same?
Same means whatever the input size is there, that is also the size of the output matrix.
Oh, I see.
So padding. Same means padding.
Sir, but why we are taking here only the same? Why not before or after? Are there any logic?
Actually, what is happening? So I didn't get your question. Means in max pooling, why we are using the same? Hello.
I think we have an intention to not lose any information from the input. That's why we applying the.
No. Maybe that is also
same,
a case.
This concept.
No. Maybe definitely because if the size of your input and size of your output is same, so there means the owner of that code will not wants to lose some information. But
Okay.
you see, if you are working with the 4096 by 4096 image size, and in that image, if you lose some of the information, then it will not create the problem. So based on your input, you have to think. You have to either go with the padding or you have to go with the stride. But suppose you are working on a very small size images like 20 by 20 or 14 by 14. And in that, if you go with the max pool of size 2 by 2, so directly you lose the 50% of the information. Yeah, so 2 by 2 pool means against the 4 values, this is 2 by 2 pool. So 2 by 2 pool, 4 values are there, and against 4 values, you are trying to put a single value. So you see, in 2 by 2 pool, directly you lose lots of information. So as your input is very, input size is very small, and even though if you lose some of the information from that input image, then your accuracy of your model is not up to the mark.
Oh, okay, sir. Got it, sir. Got it. Sir, can you suggest any pre-trained models for text related? You convey here ImageNet is it?
No, no.
Text
So
related.
professor, no. Professor, in text related, as such, there is no pre-trained model. Okay. So
okay, only image
only image
related text.
Yes. So likewise, in nowadays GPT-3, BERT, all such kind of things are there, and anyone can utilize this architecture for the means for the text analysis. So just you check GPT is in nowadays GPT-3 is there, and the research community is saying that that is the one of the most powerful text analyzer. So you have to
Hello,
check it.
sir.
Yes.
Sir, I need to clarify two things. You are talking about free trained model means which are all tested and then ready for what you call usage. You mean to say that one which are tested by somebody and then ready for deployment.
Yes. So I'll clarify. Means I would like to add more point. So let's say I think all of you know about the ImageNet challenge.
Okay.
So it was a challenge. Okay. So in ImageNet challenge, 1000 class classification is there.
What is the challenge? I have not heard.
No. Actually, as you can see in Kaggle, lots of challenges are there. CUDA Lab, some problems, predefined problems are uploaded. Okay. And if you talk about the ECCV, one international A-star conference, so they post a problem in their website. Okay. And they are looking for the research community to provide a solution for that problem. And that is open for, let's say, 6 months or 3 months, or maybe for the year. So throughout the year, the researchers, the students are trying to solve that problem. Solving that problem means they are trying to achieve more and more accuracy or more and more better performing model for that problem. So every year, everybody is uploading their research or their code in the platform. And let's say after 1 year, the result will be announced. So whomsoever achieve a maximum score, that is the winner of that challenge actually. So ImageNet was a challenge, okay, and every year the research community is participating in that challenge. So in year 2012, AlexNet was the you can say that title owned by the AlexNet. So this is the case. So why we are working on the pre-trained model? The reason behind is that let's say talk about the AlexNet itself. So AlexNet was trained on 1000 class classification problem, and millions of images are there. Even though I'll let you know, the size of the ImageNet data is 106 GB. Okay, so just you can imagine how many images are there. So image is hardly 5 or 10, even though if it is 1 MB or 5 MB, even though millions of images are there. And test data size is around 16 GB. And 1000 class classification problem is there. So you see, this AlexNet was trained on the 1000 classes. Okay, and in your problem, hardly 2, 3, 10 classes are there. So if you go and the weight and biases are already too much optimized in case of AlexNet. Okay, so if you are working with the optimized set of weight and bias, maybe possible you will get a better result or better accuracy. But yeah, of course, always remember while you are going to utilize the pre-trained model, you have to provide the changes in the output layer. You have to provide the changes in the output layer, because in your case, maybe possible only 2, 3 classes are there. So accordingly, you have to provide the change.
So what you meant to say that, sir, at the end of the layer, before connecting to the fully connected layer, we need to give our in parameters or our inputs, right?
Yes, generally what that is dependent on your, here just you can see. This is the transfer learning case. I think all of you are, yes, my screen is in shared mode. So if you have the small data set, so this is a complete architecture of any pre-trained model. And you have a very small data set. So what you can do, you can freeze 90% of the layer, or just last or second last layer you open for the weight updation, and rest of the layers you can freeze.
Sir?
Yes.
Sir, once again, what is the major difference between transfer learning and CNN, sir? Here, what is the major advantage incomparable to CNN, sir, in transfer learning?
Yes, I'm coming to that one. Let's say you have 10 samples. 10 sample for positive class and 10 sample for the negative class. I don't know, means I'm talking about a general problem. And if only 20 samples are there, what do you think? You are able to apply a CNN model for the classification? No, you cannot apply. Because in case of deep learning, it is mandatory that you must have huge data set. So if you want to get a very good accuracy in deep learning, in that case, the size of your data should be too large. Okay. But even though if you have only 10 samples and you want to make a classifier, then what option you have? So in that case, you have to go with the transfer learning. Yes, Professor, please. Are you satisfied with my answer? Hello?
Yes, sir.
Okay, so if you have sufficient amount of data, then you design your own network from the scratch. But if you have very limited data like 10 sample, 20 sample, 50 samples, 100 samples, in that case, it is suggested that you try to utilize the concept of transfer learning. So I'm talking about here, in case of transfer learning, okay, so what you can do, you freeze the 90% of the layer. Only last layer and second last layer you have to train. So what do you mean by the freezing? So while you pass your input, okay, there is no change in the weight and biases of this section, whatever you have mentioned, okay, and only updation in the weight and bias at this at here only. Okay, so why it is so? Because already this is a very big architecture trained on a very big data set. So we can say that the weight and biases are already optimized. But yeah, of course, to make this network compatible with our own data set, so we can provide means weight updation at these two things, or in these two layers only. So
Sir, one more doubt, sir. Regarding, sir, related to time series data, like, sir, maybe EG, ECG, EMG channel, signal. So, how we can use that CNN model, sir? Is it go for a use any CSV data set?
No, number one, for the time series data, RNN network is there. For time series data, RNN, recurrent neural network, you have to go with either LSTM or you have to go with either GRU. Some others are also there. But even though, suppose you know, I want to utilize CNN. So what you can do, just you convert that signal in the form of image. Yeah, so your CSV file is means what? That is a signal. Okay, just you convert the signal in 2D matrix, and using 2D matrix, if you have the matrix, then you can generate image. After generating the image, apply the CNN model. But actually, this is not a right way. But even though you can do it also.
Sir?
Yes.
What exactly mean by transfer learning?
Okay, so I think all of you know Hindi and one quote from the Chanakya. So चाणक्य ने ये बोला था कि आप हमेशा दूसरों की गलतियों से सीखना चाहिए एंड उसका एक्सपीरियंस करने के लिए जरूरी नहीं कि आप भी गलती करो. Okay, so this theory comes under the transfer learning from the others. Okay, so in transfer learning, what is actually we are doing? We are utilizing the knowledge of other person to solve our own problem.
Okay.
Okay, so already one person has solved a very challenging problem in the past. So we are following the same path of that person to solve our own problem also. It is known as means transfer learning. Okay.
So you mean to say that use the already some others models which are already tested and then experienced models something.
Yes. So what actually we are doing, already one tested model is there and we are trying to solve our own problem using that tested model. Okay, so let's say another thing is there. Suppose you two close friends are there and one friend has bought a laptop, okay, and he has been using that laptop for last 6 months and he's sharing the experience of his laptop with you that it is very nice laptop and performance is quite well, services provided by the company is also well. So now you want to purchase the laptop. So what you can do, immediately you can purchase the same laptop whatever your friend has been purchased, rather than exploring the other website, another brand, another configuration and all. So to save your time, what you can do, you can purchase the same one whatever purchased by your friend. So here what is happening actually, your friend has learned and transfer that knowledge to you, and on the basis of that knowledge you are also acting accordingly. So this is a kind of transfer learning.
Okay. But do we use in any of the whatever algorithms here? No, right?
Yes, you can use any pre-trained architecture. So many architecture I have discussed on that day. I think here, I don't know where is this slide. Let me check. Oh, I think I missed something. So some famous pre-trained architectures are there. I think that slide is deleted maybe. So what you can do, some architectures are there like VGG16, VGG19, and ResNet, MobileNet, SqueezeNet, LXNet, and ResNet. Many versions are there for the ResNet. ResNet 28, ResNet 34, ResNet 50, ResNet 128. So many variations of ResNet are also there. JeffNet, LayNet. So you can use anyone. GoogleNet. So many.
There are pre-trained models related to image set only.
Yes, for the image set only. For the text data, recently this GPT-3 is launched. So what you can do, you can go with GPT-3 also.
Sir, can you show that slide? Sir, those are very important models we have to remember, right? Can you show that slide?
I think I missed it, but let me check. Suppose I have the another version of that slide. Second day PPT. Okay, no. I'll show you. Yeah, this is the slide. Here just you can see. So this is not limited. These are the famous CNN model, LayNet, LXNet, JeffNet, Google, VGGNet 2014, VG16 is also there, VGG19 is also there, ResNet, many variations of ResNets are also available, Inception V3, MobileNet, SqueezeNet. So these are some famous CNN model. But generally what we are doing, we are go with LXNet, VG16, MobileNet, BestNet, and Inception. So 5 models generally we take for the result comparison purpose.
Sir, I have seen in your PPT classification and localization. What exactly is that, sir?
I'm coming to that point. So this when this discussion will over, so I have to cover that topic also. So means only covering the syllabus is not a good thing in my opinion. So that's why I'm discussing all these things. Otherwise, if you have the confusion, then there is no meaning ultimately.
Yes, sir.
Hello, sir.
Yes.
For related to video captioning, so
yes.
video captioning is the combination of text and images.
Yes. So in afternoon session, I'll take that example. So basically, this is video captioning is also comes under encoder decoder kind of problem. Okay, and in video captioning, you have to use CNN, you have to use ANN, you have to use the RNN also. So CNN is to analyzing the image, RNN is for generating the text.
Okay. So these pre-trained models are applicable to utilize it there as a pre-trained models. AlexNet, what you said, the set of previous pre-trained models. Is there any chance to us to apply these pre-trained models for image captioning problem?
Yes, you can. So you can use the LXNet for image analysis. For image analysis, you can use the LXNet. And after then what you can do, you use the GPT-like architecture for generating the text.
Okay.
But
so the combination of multiple models become the ensemble models.
Yes, so it is a kind of autoencoder decoder. So what using the CNN, what you are trying to do, you are converting a image as in a single value. You are encoding that image. Okay, and using the RNN, what you are doing, you are trying to decode that a single value. So it's a kind of architecture encoder decoder.
Okay, sir. Sir,
yes.
One doubt I have still, sir. All
yes.
the kinds of media, that is image, video, text, all are finally converted into digits, either 0 or 1.
Yes.
This information has to be applied, passed to the model, either CNN or RNN or LSTM or any model in the form of input. But why all the why there is a specific model for a different kind of data? For image, you are suggesting CNN model. For text related, RNN model is suggested one. Why the differentiation? Why these models are not commonly configured with all kind of data?
So what is actually happening in CNN? Oh, okay, I'm taking the example of let's say one sentence. So he is going to America. Okay, he is going to America. So I'm writing it here. Let's see. Okay, he is going to America. Okay, America. So this second term is dependent on first term.
Yes.
This third is dependent on second one. Some kind of dependency is there.
Yes.
So how you can store all
there is a
these
relationship
kind of,
between each word.
Yes. So how you can store these relation? You require some memory.
Grammar we are using for that, right?
No. Grammar is fine, but how your model know that the second one is dependent on third one, third is dependent on fifth one. So some kind of memory is required.
Yeah, some directed graph or something like that.
Capture this.
We need memory.
Memory.
Some memory.
Yeah, some memory cells should be required.
Okay, but CNN is actually lack of that one.
Yes. But if you talk about the CNN, there is no such kind of mechanism to store any kind of value.
Okay.
Question doubt clear ചെയ്ത്. Ah.
So Madhuri Agrawal Gupta, so I have you have raised the hand. You can also ask the question because already most of you are asking.
Hello, sir.
ഇന്നലെ കംപ്ലീറ്റ് ആയിട്ടില്ല തോന്നുന്നില്ല. അതിന്റെ ബാക്കിയായിരിക്കും ഇതില്ലേ?
Hello, sir.
Yes.
Sir, do you have any plan to proceed further, sir? Any topic?
Yes. Yes, I think the questions are over. Now I have to go with the object detection. Because, but the thing is that now, because all the participants have lots of doubt.
Sir, around 250 participants are there. If you are trying to clear all the doubts, means the entire session will be useless,
Okay.
sir.
Yeah.
For others.
No, only 156, 126 are there. That's fine. Okay.
Sir, please start the session, sir. We're all waiting, sir.
Okay. Okay, fine. Okay, so yesterday we have covered this.
Start session എന്നൊക്കെ പറയുന്നുണ്ട്.
Another application area of CNN where we can apply. So here just you can see in an image classification. In case of image classification, what is actually happening? A particular image or particular object is exist in that image or not, that comes under the image classification. So let's say one challenge is there, that is the car or not. So let's say in this image you are able to see that car is there, and you build a classifier model using CNN, and just you pass this image in that model. So model will return that yes, car is there, or image belongs to car category. So this is one application. Another one is there, that is the classification with the localization. So let's say car is there. Okay, so car is there, at which coordinates or which position the car exists. So that comes under the localization. Okay, so here just you can see car is there and one bounding box is there, and bounding box is basically representing that the car exists in the image at this particular location.
Hello, sir.
Next one is, yes.
I have a doubt, sir. Can I ask? Hello?
Okay. Yes.
Yeah,
yes,
actually,
please.
if my classification is not about car, say for example, I want to say that it's a scenery. So it's a road scene. And in that I want to localize an object car. So then it becomes the classification target
I'm
is.
coming to, ma'am. Yeah, in later slide you will get your answer. Don't
Okay,
worry.
thank you, sir.
Okay, so detection is there, means maybe possible in a particular scene or particular image, multiple objects are there, so that comes under the detection. So now here just you can see classification with the localization. So number one, suppose you want to put a bounding box, or suppose you want to create a square or rectangle. How many informations are required? So 4 information we have required. So let's say, suppose I have a xy coordinate. So let's say 10, 10, and this 10, 10 point is at here. And if I know the height is, let's say, 5 centimeter. Okay, so height is 5 centimeter, width is, let's say, 7 centimeter. Okay, so I'm able to draw a rectangle, or I'm able to draw a square. Okay, so it means to put a bounding box, 4 extra informations are required. So these informations are known as bx, by, bh, bw. Means xy is the coordinate. This is your bh, and this is your BW. Okay, so suppose you want to put a bounding box, these 4 informations are required, as well as you have to declare that image belongs to which class. So let's say here, just you can see four classes are there. So it means whatever image we will pass, that image will belongs to either of one category. Either it is pedestrian, car, or motorcycle, or background. So here just you can see, suppose you are working with the object detection model, or suppose you want to put a bounding box, then you in your output, or you can say that at the output level, you required 4 things, as well as you required softmax of 4 classes. So you can see that this is the target vector. Okay, so target vector means previously in the morning, I think in yesterday and the day before yesterday, we apply the ANN for the digit classification, and at there your label is like this. So let's say image belongs to class 1, then 0, 1, 0, 0, 0, 0, 0, 0, 0. This is your target vector. Okay, so label is 1 corresponding to class and rest of the position 0. So similarly here you can see that presence of an object, yes or no. If object is present and this field is 1, then you have to provide these 4 information: bx, by, bh, bw, 0, 1, 0. So basically 1 is representing, let's say I am assume that this is the motorcycle class, this is your car class, okay, and this is your pedestrian. Okay, so this belongs to pedestrian. Okay, so object is, if object is exist, then object belongs to any one of the class. If object is not there, then simply you can say that it is a kind of background. Okay, so if object is not there, then there is no need to pass any kind of. But if object is there, then you have to pass height and width, x and y coordinates, and class number. And how you calculate the loss? So for the calculation of the loss, this is the formula. Okay, so loss y cap comma y cap basically representing the predicted value, and y is basically representing the actual value. So here just you can see y cap 1 minus y1. So this is predicted by the class, predicted by the model. This is actual, and just you sum up it and calculate the loss. And your objective is to minimize the loss. Yes, anyone just can quickly type in the chat window if you have any doubt at here. Anyone in chat window, if you have any question, I can cover it quickly.
Chat window is disabled for the participants, sir.
Chat is disabled, sir.
Chat window is disabled, sir.
Okay, fine.
Sir, I think better to explain entire the time, because other participants are looking for your valuable content.
Okay. So now we come to the next part. So this is in case of object detection. Always remember your target vector has information about the class. Okay, classifier is there, and another 4 informations are also required to put a bounding box. So we come to the next part, landmark detection. So what is actually happening in landmark detection? Because let's say someone is working on face beautification. Suppose someone is working on to putting a crown on the face, then just putting some kind of Mustang. If anyone wants to put, if anyone wants to give a shape of cat and all, many apps are there. You can see that one. So if such kind of activity you have to perform, so that comes under here just you can see landmark detection. So if anyone is working on the face modification and beautification, then you have to follow a similar kind of target level vector. Okay, so here landmarks are there, and x and y coordinates of the land. So suppose if face is there, if this field is 1, then you have to provide all the information about the 64 landmarks. If face is not there, then no need to provide any kind of information. Okay, so this landmark, what are the landmarks? So here just you can see. So in a face, 64 landmarks are there. Okay, and just you can see. So let's say you want to put a crown. So how many landmarks will work? So whatever landmarks values you have to change. So these are this one. Suppose you want to put a kind of goggle. So these many landmarks will work. Okay. Suppose you want to put a Mustang, then only these landmarks will work. Kind of. Okay. Suppose you want to provide a kind of shading in the face. So accordingly, you have to provide a changes in the landmarks. So landmark 64 landmarks are there, and always remember the sequence of your landmark should be same. ऐसा नहीं होना चाहिए कि for with respect to a image 1 different landmarks are there, or means order of landmarks is different. With respect to another image, different sequence you have follow, so model will get confused. So to train such kind of model, you have to pass these 64 information. Okay, 64 information about your landmark. So another example is there, just you can see here. Suppose you want to identify a car. So for the identification of the car, you have to classify the image and put a bounding box. Now, one option is there. What is the option that what you can do? You can crop the images of the car. Okay. And if it is detected, then simply you put a bounding box in the whole image. It is the easiest way. But if different kind of images are there, so maybe in one image the car exists at the corner, in one image car exists at the center, in one image car exists at downside. So maybe in such kind of situation it's quite difficult to put a bounding box. So the solution is there, that is the sliding window detection. In case of sliding window, what you have to do, you have to, let's see here, just you can see this is a slide. So what you can do, just you move this slide throughout the image like this. Okay, likewise, like this you can move throughout the image. Size may be the different. Okay, likewise, and just you see somewhere you are able to find the car objects, then just you put a bounding box. So in case of sliding window, what is the issue? In case of sliding window, the most prominent issue is there, the size of the slide. Okay, maybe possible if the size of your slide is too small, it will take too much time to identify the object. If you make a bigger size, then what will happen? आपने इतना बड़ा बना दिया, कार एग्जिस्ट इन दिस पोर्शन, बट बाउंडिंग बॉक्स जो आया आपका वो बहुत बड़ा आ गया. Okay, like at here you can see. So this is the problem with the sliding window, size of the sliding window. Number 2, huge computational cost is required because you have to slide that window throughout the image. Okay, so computational cost is an issue, as well as size of the sliding window is also issue. So 2 issues are there, but even though how we can solve that one, we can see it here. Okay, so before that, just I'm coming to one important point, how we can convert the fully connected layer in the convolution layer. So I think if all of you remember, in NVIDIA lab number 4, GPU task 4, okay, NVIDIA GPU task 4, what we did, we have changed the architecture of, I think, LXNet, okay, where we have converted the fully connected layer, FC layer, by the convolution layer. And what was the effect? Effect is that before conversion, the inference time was 0.79 second. Okay, after converting fully connected in this convolution network, it is 0.12 second. Okay, so here just what we are doing, we are trying to convert the fully connected layer to the convolution layer. So here just you can see 14 by 14 by 3, okay, 3 channel image is there. 14 by 14 is the size. 16 number filters are there. So, and 5 by 5 is the size of the filter. So it is 10 by 10 by 16. After max pooling, it is converted in 5 by 5. And here just you can see this 5 by 5 by 16 using flatten. So these nodes are connected with 400 nodes, okay? And these 400s are connected with another 400 and then softmax. Now, here just you can see how many values are there. So here you are able to see that 400 values are there. And we have converted this layer as a convolution layer by 1 by 1 by 400. Here we have also converted 1 by 1 by 400. And here also we have converted the softmax layer. So in softmax layer, 4 classes are there. So we have converted it by 1 by 1 by 4. So all the fully connected layers are converted in the convolution layer.
Sir, Gupta sir?
Yes, I'm there.
Yeah, okay. Sir.
No, I am still reading the chat. Okay, so that's why. Okay, so here just you can see the convolution implementation of the sliding window. Okay, so this is our neural network. Here just you can see 14 by 14 by 3, 10 by 10 by 16, and then 5 by same. Means it's not a too big deal. Fully connected layer, fully connected, and then fully connected layer. Okay, so here just you can see size of each layer, 14 by 14 by 3, 10 by 10 by 16 due to this operation. Then max pooling due to this max pooling, 5 by 5 by 16. Okay, after then 1 by 1 by 400, that fully connected is converted. Then again fully connected converted, and then at the output layer 1 by 1 by 4 is there. So here just you can see again, so 16 by 16 by 3, again I'm discussing how it is converted. So the whole image of like this 16 by 16 by 3, and we are passing this information in this convolution neural network. Okay, so it is first converted in 12 by 12 by 16, then max pooling 6 by 6, then 2 by 2, yes. So 6 by 6 by 16, if you apply the 5 by 5 filter, so 6 minus 5 plus 1 equal to 2 by 2. Okay, why 400? So this 400 is there due to the, so 2 by 2, okay. 400 nodes are there after fully conversion, that's why it is there. Then again 2 by 2 by 400, and then 2 by 2 by 4. So here just you can see how we can try to understand what is actually happening. So the whole image is represented by this matrix. Okay, what is this matrix? 2 by 2. So 2 row and 2 columns are there, and with respect to each row and each column, 4 different values are there. What are these 4 different values? So in our case, car, background, okay, pedestrian, and what we call the motorcycle. So 3 class are there. Sorry, pedestrian, background, car, and motorcycle. So with respect to each cell, 4 values are possible. Okay, and what are these 4 values? Any one of the class number. So we have converted this the input image in form of 2 by 2 by 4. So this, if you divide this image in 4 quadrant, so first quadrant is presented by this section, and it is represented by this one. Okay, and this is represented by this one likewise. So this kind of mapping is there. So basically in sliding window, we had to generate a kind of convolution neural network, and in that convolution neural network, just you pass that window or that image, and with respect to number of quadrants, you have to set that at which quadrant any object is there. So similarly, you go with the 28 by 28. And another one is there, the most important performance evolution metric is there in object detection, that is the intersection over union. So let's say multiple bounding boxes are there. Okay, so here just you can see one bounding box is there with this blue color. Okay, and another bounding box is there with the red color. But actually your car, where your car exists. Okay, so if multiple bounding boxes are there, then what you can do, you can go with the intersection over union kind of thing. So intersection over union means you have to take the intersection out of the united area. So your car, or you can see that this section is there, which is representing the actually car. Okay, so maybe possible okay, so if cars are closely parked, at that time such kind of situation is there. Okay, so in such kind of case you can go with the IO operation, IOU, intersection over union, and it should be greater than 0.5. Maybe possible, and another kind of state is there. So in that state, what is the case? Anchor boxes for overlapping objects. So in this image, you can see that one robot is there and one car is there. Okay, so what you can do means two objects are there, then there should be two bounding boxes, and each bounding box will represent a different object. So in such kind of issues, the concept of anchor box has been arised, and here just you can see two anchor boxes are there. So one anchor box for the vertical, okay, so vertical kind of object, another anchor box is for the horizontal objects. Even though robot kind of things are there, so maybe robot stand in the 45-degree or kind of that is quite possible. But with the help of two anchor boxes, you can provide a bounding box for each object. But maybe yes, let's say one object is there at here, so you can use this anchor box, and with respect to each anchor box, you have to provide some other kind of information also. So here just you see each object in the training image is assigned to grid cell that contains object midpoint and anchor box for the grid cell with the highest IU. I'll let you explain again. Okay, so always remember here we are going to use two anchor boxes. So with respect to anchor box, you have to provide, you have to provide 8 information. What are the 8 information? XY coordinate, okay, and height and width, and C1, C2, C3. So basically C1, C2, C3 is representing the class number. Class number means like main, motorcycle, car, bike, what class is there? Okay, so class number is there. Our class number is defined by C1, C2, C3. PC basically representing the anchor box. So anchor box 1, anchor box 2. With respect to each anchor box, you have to provide the 7 other information. Okay, and then you train your model. Similarly, in case of YOLO, so I'll let you know there are many versions are available for the YOLO. You only look once. Okay, so YOLO 1, 2, 3, even though tiny YOLO is also there. YOLO 4 is also there. So tiny YOLO is useful to deploy on the Raspberry Pi and all. So someone has asked about the how we can detect the number plate. So yeah, of course, to detect the number plate on the highway and all, you have to install the camera. Okay, so in that camera means the position of the camera in such a manner so that that camera capture the images of number plate also clearly, and you have to pass that image in the model, and model has to segregate the means model has to identify the area of number plate, and then you have to apply the OCR and all, and then you are able to get the what is written in the number plate. Okay, so in case of YOLO, already the codes are available in GitHub. You simply download it. There is no training weight and all. Simple code is there, so you have to pass the path of your data, and you can easily easily you can check it. Object, what kind of object is there. So already in last month we have implemented, and we have applied this YOLO on the drone data to identify the security, means army vehicle as well as the pedestrian, motorcycle, car and all. So it's quite easy, hardly 4 or 5 line of means around 10 line of code is there. 10 line code of YOLO is there, but yeah, of course you have to map that code with respect to your training data. So what is the functioning of the YOLO? So here just you can see. Okay, so here just you see. So the whole image is divided in grid of 3 by 3. Okay, with respect to each grid, 2 anchor boxes are there, and with respect to each anchor box, we have to pass the 8 information. So here just you can see your the target vector is there. Just you see. Okay, so this is your target vector. So with respect to a grid, 2 anchor boxes are there. With respect to each anchor box, 8 different values are there. This is the target vector, and on the basis of this target vector, you have to train your model. Okay, so some yes, of course, you can utilize the YOLO, but you have to train that model. After providing the training, your model will identify the objects and all. So YOLO is also there for the object detection. Faster RCNN is also there. Okay, so in faster RCNN, basically the concept of faster RCNN is it is working on the region proposal network. Many RCNN are there, RCNN, fast RCNN, faster RCNN. So everywhere the background theory to detect the object is that whatever we have discussed about this anchor box and all. Okay. So in case of faster RCNN, always remember two things are there. One, convolution network is there, and that network is required for classifying the object. And okay, so first one is the classifier, and class, and second part is also there, that is the region proposal network. And this region proposal network is basically trying to identify the region where object exists. So I'm not going to too much detail. Okay, so here just you can see how region proposal network is work. So generate the anchor boxes, classify each anchor box whether it is foreground or background, learn the shape offset for anchor boxes to fit them for the object. So again, it's also a kind of a combination of YOLO, anchor box, and then sliding window. So on the basis of that, they had tried to combine all the theory and generated a new kind of theory known as RPN. So face recognition versus verification. So yesterday, one person has, I think, asked one question about the pattern matching or face matching. So here, just you can see, I'm covered it. I'm not taking these two slides. This face recognition versus verification. It's a kind of theory, so you can go through that one. Okay, so here just we try to understand. Okay, so here one CNN network is there. Okay, so let's say in my organization 100 employees are there, and I want to take the attendance of all 100 employees using webcam. Okay, so what you can do, where the role of the webcam is to capture the image. So it will capture the image, and that image will pass in the CNN network. Okay, so this is your CNN network. So in this CNN network, what I am doing, I am not going for any kind of classification, because if I go with the classification, then I have to create 100 classes. Okay, I have to create the 100 classes. So it is not a kind of classification problem. Now what we can do, just I am removing the last layer or output layer. Okay, so because here just you can see this is the CN network, but here no classification kind of thing, just I removed it. So before removal, here just you can see this is the fully connected layer. I stopped that here. Okay, so at fully connected layer, this nodes exist in this fully connected layer, store some of the values. So with respect to a single image, I created a vector. Okay, so with respect to this, I can say that at fully connected layer, I found these many values. Okay, another image I can pass. Okay, similarly, I can generate next similar kind of vector. Okay, so for 100%, similarly 100 vectors are there. Okay, now a new person will enter in the your organization, and just he or she put the face in front of the camera. So camera means the background model will pass the captured image throughout the network, generate a vector, and this vector and the model, what will do, the model compare the similarity between the new entered vector with the existing data set vector. So for the comparison, what we call for the similarity purpose, we can go with the cosine similarity. So this is a very popular term, cosine similarity. Okay, if similarity score is high, so what you can do, you can define that the person will exist in the organization. If similarity is low, then person not belongs to the organization. So here just you can see, I would like to match this image and this image. So what I can do, the same image you pass in the same kind of architecture, that image also pass in the same kind of architecture. There is no output layer, so you will not get any kind of classification. Simply you compute this fully connected vector using the cosine similarity. Okay, compare it. After comparison, if similarity score is high, so you can declare that both the images belong to same person. If score is low, then you can declare that the face is not matching. So those who are working in the biometric pattern matching kind of problems, they can utilize this SIMES network. It is also a network proposed by some scientists in the past, and you can utilize it for your own pattern matching kind of problem. Okay, so just I'll look for the chat and let me see what kind of questions are there. Yes, I'll share the PPT, don't worry for that. Okay, fine. So some of the comments are there, means in case of medical imaging, is it necessary to annotate it or else can we use segmentation tool? It's up to you, I can't say anything, because based on your problem, because predefined medical segmentation, medical labeling tools are there. Okay, so you can use that tool. If you want to do segmentation, you can go with the labeling tools if it is required, or suppose you want to pass your data for the classification purpose in a CNN model, you can also pass. But I don't know, means you have to go for some kind of what we call hit and trial method. No, how do we divide the data for the training and testing? Generally, from where you will get the data. So generally that is divided in the two parts, train and test part. But even though if it is not there, then what you can do, based on the number of samples, you can go with the either 80-20 ratio or 70-30 ratio, even though you can go with the 95-5 ratio. So you can go for that one. CNN only for static images, it is not for the video, okay? Because video comes under the time series data. Okay, so for the video analysis, you have to go with the combination of CNN and RNN, or even though you can only go with the RNN. Okay, so these are my input. So is CNN is only meant for image processing? No, that is not a image processing. So CNN is only meant for the performance of CNN is good if you pass the data in form of images. Okay, even though means if you want to pass the some other kind of data like in video or in Excel file data, if you apply the CNN, nobody will stop you. Ultimately, you are working on the numbers. Okay, so in Excel file again, numbers are there. Okay, and in the image again numbers are there. So you are playing with the number. Okay, so I'll share the PPT, so don't worry for that. Okay, so please start a lab. I think all of you didn't completed that lab. because even though I have checked it, how many of you have cloned it? So please that complete the CNN lab and it will really help you. Okay, so many exercises are there at the bottom, and most of you didn't go with, because one popular question is there. Here just you can see, because all of you didn't go through the PPT. Otherwise, at least one of you will ask the question. And what is the question? I'll let you know. The question is that, here just you can see, so this is the question: trainable parameters and non-trainable parameters. Okay, so let you explain what are the trainable parameter and non-trainable. So trainable parameters are such parameters which are means which the value of that parameter will change in each iteration. Okay, or the value of that parameters will change or updated. Non-trainable parameters are there. So non-trainable parameters are such parameters, okay, during the execution of the CNN model, there is no change in the value, but they are required in between to perform some of the operation. So non-trainable parameters are there, like standard deviation, like mean, okay, and so many popular statistical terms are there. So all such kind of parameters are that parameters. So let's say once at the initial point or initially you have calculated the mean, and that mean is utilized in any manner during the execution of the CNN model. So what we call, so at that time, that variable is utilized, but there is no change in the value of that variable. Another thing is there, here you can say that trainable parameters. So trainable parameters are the weight, bias, batch normed values. So these are the trainable parameters. Trainable parameters means during the training, regularly they will be trained automatically. Okay, so in each epoch, the value will change. Okay, so in at 3:30 we will meet, and I'll cover the LSTM. Okay, so LSTM and corresponding lab is there. So we will cover that one.
Sir, Gupta sir?
Yes, so Professor, my lab is there from 1:30. So
okay.
I have to leave the session. Even though just all of you post your queries, so I'll try to answer or cover in any manner. Okay, sir?
Yes. Yes, sir. Thank you, sir. Thank you very much.
Okay, thank you.
Mallikarjun, sir, please cover RNN. Okay, sir. I will convey the message to the speaker. I request all the participants join the session before 20 minutes so that speaker will cover more information. Okay, already we sent a feedback form. Please fill the feedback form. Jupyter link, one of the participants is asking, is anybody copied? Please post in chat box. So recording exam 30 bits, quiz type, 30 minutes. Yes, sir. Well, sure, sir. Sure, sir. First, I convey the message to the speaker. First, go for covering of the concept. Then last 10 minutes, we will go for questions and answers. Okay, sir, I will take PPTs from speaker, then I will forward you. Yes, sir. Yes, sir. Bipin.